Welcome to the last session. And thank you for staying. So, this is actually my first in-person conference in the last 2 years. So I'm really excited. And unfortunately, it is in the spring, and I have allergies to pollens, although I haven't seen the blossom. So if I cough in the middle, don't panic, okay? So yeah, within the next probably 15 minutes, I will talk about how we leverage natural language processing to extract insights from earnings calls transcripts. So basically, my motivation comes from the challenges our industry has facing in the last decade. So if you see this plot, it shows the percentage of asset managers who outperform the broad market index in the past in the last 20 years. So as you see, in majority of the years, less than 50% of the asset managers actually outperform the market. So basically, this is unacceptable to our clients. And asset managers like us, AllianceBernstein, we really need to work hard to find different ways to increase our odds of success in order to serve our clients better. Then we are thinking about using alternative data and big data to the rescue, right? And you probably heard about the definition of big data. So what is big data? They usually define it with 3 V's. First, volume, it means there's more data. Second, it is velocity, means you get the data very, very quick. And the third, variety. So you not only get numerical structured data, you also get text data, unstructured video data, images, all kinds of different modes, right? And I would like to add the fourth V, which is veracity. This is very crucial for finance because it is only about the accurate and reliable data we use. We can get the real signals. We can, make it work, make us outperform. You probably heard of it. In finance, most of the data has very low signal to noise ratio. Yeah, there's a lot of Twitter data, like social media data, news data. It seems working for the market, but when you use it as a systematic signal in your strategy, it doesn't, right? So then that's what we want to use about, okay, I cannot go back, so I will just talk through. Last slide, that's where we use machine learning and AI models to generate a large number of features and to see whether they can help. And we actually also collaborate with our investment teams, like asset managers, portfolio managers, advisors, in order to really make use of those information. So today, what I will show you is how we apply natural language processing techniques on earnings transcripts to generate those signals. It seems automatically change back and forth. But anyway, so basically, many of you may heard about earnings calls, may even attend some of the earnings calls, right? So that's the companies, public companies, they need to disclose their earnings information to shareholders at the end of each fiscal quarter. So they hold the calls, and then their calls was transcribed into transcripts. We get the transcripts, we apply our feature engineering pipeline, we get the features, then we use different type of models to backtest them, to see whether they perform good. They can help us to, make more money. So then for those better performed ones, we will push them to the investment teams. They will incorporate it into their systematic strategies, models, to see whether they can use it in a long run. So I want to give you, before that, I want to explain about the earnings calls a little more to give you more structure about the data. So basically, earnings calls are composed of 2 sections, the presentation section and the Q&A section. In the presentation section, it is mainly the company executives, like CEO or other executives, CFO, to talk about their earnings, their performance in the last quarter. Then in the Q&A section, this is the audience ask questions. Majority of the audience will be analysts who covers the component. And then it will be either the other executive or the CEO answer the questions. So here I'll show you the pipeline or the workflows we developed in order to work on the data. First, when we get the transcripts, we put them into MongoDB. Then we definitely need to do some pre-processing, like remove some of the irregular characters and remove some of the stop words or tokenization, lemmatization. It depends on the specific model we use later. And for the feature engineering, I listed a few here, like sentiment signals, readability scores, which I will show you more details in the next slides. And this is definitely utilize models or approaches from the prehistory to the Bronze Age, right? So the last one is, next one is the label engineering. I call it label engineering, but typically portfolio managers wouldn't see so. Because I would use some traditional finance methods to backtest the signals, as well as some machine learning methods to see whether there's ways I can efficiently combine the original features to make a more stable, useful signal. So in the modeling part, we use either supervised or unsupervised. So I list it here because on the feature engineering side, I'll show you next slide, specific features. It's mainly about supervised, how we use it. But some of the topic modeling, or information retrieval we applied, are also useful for our advisors when they talk to the clients. So here you see the feature construction from earnings transcripts. And basically there's 3 categories I show you here. The first category are the dictionary based from the prehistory. So basically this is back-over approach. We use 3 types of dictionaries. Harvard IV4 are from psychology, so it is more generic, like sentiment from people's regular emotions or talkings. And then it is Vader. Vader is more applied to social media and short text, like reviews on Amazon. And the last one is a Zofran McDonald. It was initially developed in 2011 by these 2 professors, Lofran and McDonald. And it was developed from the 10K, which is the filings for public companies to the SEC. So it is said it will work better on financial documents. So we have high expectation on its performance on the earnings calls transcripts. Then the next one is a sentiment-based. Basically, we use FinBERT. And FinBERT nowadays has become a generic term. It refers to the use of the BERT model in the financial domain. So there's a few kind of sentiment factors we generated because BERT applies on the sentence level. How we aggregate it is some things we kind of mining, and it turns out at the end, we use some net sentiment from the sentence level, just the mean aggregated to the transcript level or section level. So some of the others, very briefly, like accounts, number of words, questions, some of the CEO characters, like they are more individualistic oriented or group oriented, and some of the readability scores, kind of towards 2 dimensions, like the number of difficult word counts and the sentence length. So here I show you very briefly about the features. This is a count feature, how many sentences there, how many words there. And next one is the readability feature. It's so easy to understand from the blue box. The short text is simple, easy, so it has a low readability score. And the gray box has text that is 1 sentence so long and complex, so it is difficult to understand. So here's the dictionary-based sentiment. So you see the positive words and the negative words, so we get the percentage, and then subtract it to get the net sentiment. Okay, I didn't expect there's some animations, but that's fine. So yeah, for the sake of time, I'll quickly go over the performance of the features. So basically, there's different sections, and we generated the features on each single section as well as the combined sections. For example, we combined the CEOs about their presentations and answers, and because we think we definitely would separate the executive from analyst, because we think for the executives, it is more prepared remarks, and they tend to speak more positive about their component. But for analysts, it will be more straightforward questions they care about. So here's a backtesting strategy, very simple and commonly used in finance, is you select one feature and you rank order them into 5 quintiles, and you select the top quintile and the bottom quintile for each of them, the components which have the stocks. And then you buy the top quintile, you sell the bottom quintile, then it is a long-short portfolio, right? And here the plot show you the annualized return in each of the quintiles from Q1 to Q5. This is relative returns, like means it is how it outperforms market. So here, based on the plot, you see that it is consistent with our priors, that higher sentiment lead to better performance and low sentiment lead to worse performance. Although it is not strictly linear, because you see Q2 outperforms Q1. Yeah, and next slides, I want to show you about some interesting findings of it. Besides, some of the LM sentiment features shows it works, and we see that there's a difference between the CEO and analyst sentiment on the US earning calls. So here you see for the blue line, it is a CEO sentiment, it is much higher than the analyst sentiment. And that makes sense. CEOs speak positively about their component, and for the analyst, it is mostly neutral questions. And we also see there's then this is a performance of the CEO and the analyst sentiment in terms of the yearly growth. Suppose you have $100 in 2016, and then if you keep using this strategy to invest and rebalance each month, what is your, what is the performance at the end of 2021? And it turns out the analyst sentiment performs better than CEO sentiment. So we think there's more information content in the analyst question section. So next one, I'm turning to the Bronze Age, which is a context-driven sentiment. So here I show you a few sentences. If you are using the dictionary-based and you are using the context-driven BERT-based, you see the context-driven BERT-based gives you much better or reliable sentiment evaluations. Just using the first one, like thanks for taking the questions. Question is a negative words in LM dictionary. That's because LM is developed from 10K. And in 10K, if you see something, there's a question, it is really questionable. So, but in earnings calls, this is a common word used in the QA section, like thank you for your question, who is the next question, those things. So that's why the LM dictionary base sometimes doesn't apply to the earnings transcripts really well. So next one, you see the performance of the dictionary and context-driven approaches using the theme like $100 growth. You see that the context-driven approach performs slightly better than the dictionary approach. So we have in total around 500 features. This is due to the data mining consequences, I would see. Usually, if I talk to portfolio managers, they don't like that way because they think there may be some noise or randomness leads to the good performance. So then we actually get the IR information ratio for all the around 500 factors, and there's around 30% performs really good, means their IR is higher than 0.5, and there's around like 5% performs extremely good, means their IR is more than 1. Then we would select those good perform ones and the extremely good ones, discuss with the investment teams like fixed income, equities, or multi-asset to see whether there are ones are more stable if we test it in different strategies, and whether those has economic intuitions behind them instead of purely data-driven. Okay. So for the summary, there's a few bullet points, just to summarize that we think this approach helps. Based on our simple backtesting of all the factors, there's a large number outperforms. And, but I want to emphasize that although it shows that machine learning and AI can help, but we do bring in the human insights and combine them together in order to generate a more meaningful strategy and be more interpretable to our clients. Yeah, that's basically about it. Thank you.
Great. Thank you, Yuyu. Great presentation. Any questions? We'll take one question for her if anyone has one.
Yeah, I think everyone is looking forward to the end.
Yeah, I think so.
Yeah.
We have one over here. You have one question here.
Okay.
Yeah, thank you for the talk. So kind of wondering, it seems like you've got cross motivations here. So you said that for active investing, you want to look for, normally you're looking for stocks that are potentially overlooked, like everything else is indexed. You've got passive investing, all the large cap stocks are being covered. Then I assume that this would be more relevant for looking at small cap and mid cap, yet wouldn't that also be the stocks that normally wouldn't have as much analyst coverage? So you'd have less data and less signal to work with for this NLP approach. Is that right?
Yeah, thank you. Actually, I don't have time to cover all of this. We tested on different universe, US large cap, US small cap, on the developed market, international, as well as emerging markets. And as you said, it performs best on US small cap. For EM, it's not stable because we don't have enough data for earnings transcripts. But for large cap and international, like developed world, it's just okay. Yeah.
Thank you.
Okay, thank you.
Great. Thank you so much.